Ah. Ah. Okay, that was a good idea. Right, thank you. Good morning, everyone. Welcome to Multipath TCP Part 2. The blue sheet has started going round. Now, it's the noise from out... Oh, somebody's shutting the door. Thank you. So we need a note taker, please. Can somebody volunteer? And a Jabber monitor. You take notes. Thank you, Brian. Somebody able to keep an eye on Jabber, which is very easy. At least if your computer lets you do Jabber. Thanks, Mia. The note well, of course. So we had a good time on Monday talking about, or Tuesday rather, talking about the implementation updates, the BIS and some proxy stuff. So I thought, since there's been a lot of discussion on the list in the last couple of days about both the converter draft and the SOX draft, I really wanted to give people a chance to follow up orally in the in the face-to-face session on those two drafts. So does anybody? I mean, there was kind of a burst of discussion which has actually died down in the last day, which maybe implies we have some consensus on it, or perhaps just implies that people have got other things to do at the moment. Does anybody want? I mean, I've allowed some time in the agenda basically now for people to follow up on either of those, the converter draft, or on Vlad's SOX v6 draft. See, people are still coming in. So if there's a moment that people have to follow up anything. So I'll tell you what my my interpretation and the way forward. I think on the SOX v6 one, that's, I think that will not be homed in this working group. And it was great that we heard about it. So I think we will continue to hear about it, and I'm assuming that it will go forward in int area or somewhere similar. So that's great. And I think it's good that we remain in the discussion, but I don't think it's unlikely we'll be the working group leading it. On the converter thing, my read of the discussion that happened for kind of on Tuesday and Wednesday in particular was quite promising, and that people seemed to quite like the approach, and the people who'd had issues on previous approaches, which was particularly Joe Touch and Tom Herbert. And it was great that they made lots of comments, and I think they were probably reasonably okay, but I mean, we have to obviously confirm that and give people more time to read it and for others to chip in. So unless anybody wants to make any further comments and follow up any of the points, my suggestion is that the authors of that draft do a rev, a new version, taking account of the comments, which were lots of clarification things. Do a revision. We'll ask for comments again on all the relevant mailing lists, and then we'll work out with Mia what the right working group is to do it, because you know, it obviously should be the call for it to be adopted has to say what working group will work on it. So that's my suggestion of how we're going to go forward with it. Okay. So if nobody wants to chip in any more on the proxy work, we will move on to topic 2. So topic 2 today is a new security attack which Zion and sorry, apologise for mangling your name. Zion and colleagues raised a couple of days ago on the mailing list, and this was really great that they brought it forward and notified us. And there's been some nice discussion in the last couple of days of it. So for those of you who haven't caught up, I've tried to extract some points from the email. Now let me just look at Mptcp. I don't think the authors are on Mptcp, so I will attempt to summarise the problem that they raised. So this concerned the MP prior message, which is, and the problem is that it seems to allow a man-in-the-middle attacker on one path to divert all the traffic onto its own path, so effectively hijacking the Mptcp connection. And when we were designing the Mptcp protocol, there was a security assumption it would be equivalent to, or roughly equivalent to TCP security. So on-path attackers are a vulnerability for TCP, but this is probably a bit worse than that. And there's a little explanation there about why you might be interested in sending the MP prior message on another sub-connection, and it might be that the first one you've got is already congested, so you can't really send it on that. The MP prior is about indicating whether one of the sub-connections, one of the subflows is kind of to be used as a backup path or not. So it's a kind of mode in which you're using it. So the issue really is that the MP prior option has no authentication required. So that's the vulnerability, if you like, that this proposed attack is exploiting. So the solution that that Zion and others have suggested is, the possible solution is to remove the address identifier from the option. And my read of the discussion that was on the list is this was seen to not have very many downsides, and that it would cure the issue. So we ought to have some discussion, so I'll throw open the mic. Alan.
Hi, Alan Ford. So just to summarise a little bit more, MP Prio is a backup bit for use on other subflows, predates the fact we can do the Prio bit in the MP join. So that's pretty much negated the point of this signal anyway. So as far as I'm aware, there's no problem with removing this. As regards the actual attack itself, the scope of it is very, very small in that it requires only enough bandwidth and so on, and relying on the policy of the other end to apply backup in a certain way, and requires it to be an on-path attacker, which is, as I said on the list, pretty much equivalent to a TCP level attack anyway. Having said all that, not a problem to get rid of it, as far as I can see. So the real question to everyone is there any reason to change your priority of a subflow from another subflow? And if there's not, then I feel we've clear to get rid of it.
So Olivier Valenture, I think the attack is important in practice because you have, let's consider one case where you have a smartphone and you are connected to a Wi-Fi access point and a cellular network. if you control the Wi-Fi access point, then you can tell with the attack that the cellular network should not be used to transmit data. So you move all the traffic over the Wi-Fi access point. And the reason is that in the MP prior option, and I don't remember for which reason, we have placed an address identifier in addition to the bit. And this address identifier should indicate that you would put as a backup all the subflows that are using this specific address identifier. And this is a really strange use case, and as far as I know, no implementation is doing that. So I would support the removal of the address identifier from the MP prior option. And if you remove the address identifier from the MP prior option, then you are forced to use the MP prior option on the subflow that you want to change the backup status, which means that you need to be on path to attack this particular subflow. And I think this solves the problem, and we keep the protocol simple and usable.
Any more comments? So let me ask the question, is there anybody unhappy with this proposed solution? If you're unhappy with this proposed solution, please can you hum? Okay, so I heard nothing. And if you're okay with this proposed solution, please can you hum? And if you would like more time to think about it, say another week, please can you hum? Okay, so for the notes I heard some humming on the happy to remove it and none on the other two. Nobody was unhappy with removing it and nobody needed more time to ponder. So, Alan, as editor, can you go ahead and make the change? Thank you. Right, that's great. So, this is good. We're well ahead of time. So, Marcus is up next to talk about this proposed MPT robust session establishment. So, let me see if I can get all slides.
Yeah, good morning. My name is Markus from the company with the magenta color, as you can see. It's Deutsche Telekom. And yeah, today I want to talk about a real existent and annoying problem we were faced with the standard Mptcp into the field. And yeah, my goal for today is that I can gather some feedback from your side, because it's the first time for me at IETF and I'm not pretty familiar with the process here, so please support me during yeah, the presentation or afterwards. So can we go to the next? I think that we can skip directly and we can hurry up a little bit. Okay, so I have an example where I try to explain the problem we are faced. First, we start with the standard Mptcp. And we have you see a smartphone, and we assume that it is system-wide enabled with standard Mptcp. And as you know, a smartphone today has a Wi-Fi interface and a cellular interface. And if it tries to connect a MP-capable receiver, it will work like that it first tries to open an initial flow over or through the default route. And if it is successful, then afterwards, it can open subsequent flows. So I think most of you know this process, and yeah, as soon as two succeeds, the second point succeeds, so you have a subsequent flow, then you have multipath capabilities, which means resilience and possibly bandwidth aggregation. Yeah? But first, you need the first point, the initial flow, and then you need the second point, the subsequent flow, to have multipath capabilities. Okay, next slide, please. That's again the flow diagram for the session establishment, and here you see again on the left side the two interfaces, A1 and A2 from the smartphone, and on the right side the host B interface from the server. And first we start the request with an MP capable for the initial flow, and if it succeeds, then on A2 we can start with an MP join. Next. Okay, what is now our problem or the motivation for our proposal for a robust establishment? What happens if the default route is not able to transmit or succeed in reaching the server, in establishing an initial flow? And the answer is pretty simple: nothing will happen. Even if you have another working path, yeah, for example, the cellular network, you cannot reach the destination, and it's a problem. So the question is always, where do you put the default route? Should it be on Wi-Fi? Should it be on cellular? We don't know. And at the end, it could happen that we will never reach the destination, or we need some mechanism which tries to detect where we have to put the default route to. Next slide. Okay, and now our demand is, or our approach is, if there's at least one functional path, a connection must be possible. That is our idea, and that I want to present now. The idea is mainly based on introducing potential initial flows. So do not have any more the concept of one initial flow and then subsequent ones. We want to have potential initial flows using all paths available during the establishment process, and do not rely anymore on one path. And that is what you can see here now. We directly start on both interfaces potential initial flows. And even if on the default route it cannot succeed, it will work over the cellular. So any path can be used to establish a connection. That is the idea. And for that, we developed 3 different proposals I want to present now. Maybe there are also some other ideas, but we try to make some, to develop some different proposals which have different kind of aspects in kind of robustness, in kind of other benefits, and that I want to present now, and maybe then you can afterwards give me some feedback which one fits best from your view. So next slide, please. Okay, and that to directly say that is the preferred proposal from our view, and it's pretty simple. So what we are doing there is we establish over each path from the very beginning identical synths. That means we copy or we duplicate the MP capable, which we send to host B, and the first flow that returns establishes a connection, which at the end resembles the initial flow concept. And the second flow, and that's what we call downgrade approach, we directly use and downgrade it as a subsequent flow. That means that at the end guarantees robustness and overall latency reduction. Why overall latency reduction? We have 2 things in respect to latency. First, the quickest path enables communication. And secondly, we have the path, all the flows earlier available, and can use them, for example, earlier for bandwidth aggregation. And the last point, we do not introduce with this concept any kind of network overhead. Next slide. The second proposal is pretty similar to the first one. So we start again with duplicating the SYN requests for all paths available. But now there's a change on host B side during the handling of the last acknowledgement which will arrive at host B. So we reset all but one. That means the first flow which returns on host B will be the initial flow, and all the other ones are reset. And then we can proceed with the standard mpjoin procedure. Yeah, that guarantees robustness as well. We have some latency reduction, so it's not the same as with a downgrade approach. So the quickest path in game determine the handshaking latency. But then we reset all the others one, and again we have to use the mpjoin. So the subflows will not be there earlier as in the downgrade approach. Yeah, it's then like standard Mptcp. And we cause additional network overhead because we have a lot of handshaking, which at the end we reset. Yeah, and the last proposal that we call the timer solution, we don't like it, but it has the benefit that it is full standard compliant. But compared to the two other proposals we have already seen, it is less efficient. And of course, it guarantees robustness as well, what we are doing, and that is pretty like the happy eyeballs concept from RFC 6555. We start with a normal SYN request over the first interface, over the default route interface. And if after some time we do not have success in establishment a connection to the receiver side, then we try it on another interface. And if you could assume that can introduce a lot of delay, because we have to recognize that one or several paths will not work. Imagine, for example, if we have 8 paths available and only the last one works, then we have to try 7 paths before we reach the path which is working. And I'm not sure if this is a good solution, but I say it again, it's full standard compliant from my view. Yeah, next slide. Okay, again, a comparison. We start on the left column with the downgrade approach. So it's most efficient in terms of robustness, overall latency reduction, and I think that is a huge benefit also compared to the standard Mptcp. And we do not introduce any additional network overhead for such an approach. But it needs sender and receiver modifications, possibly some standard extension. And there I'm pretty sure that we need some standard extension for such an approach. And yeah, at the end, it's the most challenging one in terms of the standard extension and of implementation. Now to the middle column, break before make. It also provides robustness. It has an initial flow latency reduction, so compared to the downgrade, it's a little bit less efficient. Yeah, again, it needs some sender and receiver modifications. It will need some standard extension, I guess. It's challenging as well. And we introduce some additional network overhead because we have to reset all but one, and then we have to proceed with the mpjoin again. On the right side, on the right column now, the timer solution. So it provides robustness as well. That is why we are doing that. The implementation is pretty easy because you just have to do it on sender side. It's full standard compliant. Yeah, but as already mentioned, less efficient in respect to latency and network overhead, probably. Yeah, and we have possibly latency increase by such an approach. You define a question in between, or?
No,
okay.
For now.
So we defined some criteria to evaluate our own proposals we made, and obviously the important point the importance point is robustness, and all of them fulfill this criteria. Then compared to Mptcp, so to standard Mptcp, the network overhead should be minimized. And that is true for proposal 1 and proposal 3, but not for proposal 2, because we reset all the unnecessary initial flows or potential initial flows. The latency, also compared to standard Mptcp, should not be increased. And in the best case, we can also reduce it. And that is fully true for proposal 1, because there we can or we will reduce the overall latency, because the quickest path or the quickest potential initial flow will win and establish a connection. And yeah, for proposal 2, we will not increase the latency, and we will have some little reduction. Direct question, or should I first finish this?
I have just a little question. Hi, my name is Uma from Huawei. Very good draft. I quickly skimmed through it. I didn't understand why you didn't put MBB kind of make before break. Is it not applicable at all in this case, or?
Sorry, can you repeat the last sentence?
We have this MBB, right? Make before break.
Yeah.
Was very heavily used in. I'm a routing background guy. So why not this is applicable here? First you make the connection, then break it.
So if I understood you right, that is a proposal from us, but
that is downgrade. That is the proposal 1.
We prefer the proposal 1. That is just our view on that. But break before make is also a proposal, and if you like it, why not? So that is why we discuss it today.
Okay, I will take it offline. I have specific on proposal 2. I have some comment on that.
Yeah. Okay. Yeah, and with proposal 3, we will most probably have some latency increase in the case if the default route is not working, and yeah, we will not reduce the latency compared to standard Mptcp. Yeah, the last point is standard compliance that I have to explain a little bit. So we assume that for all proposals, either we can directly incorporate with the existing Mptcp standard, or we need just minor updates of the standard, but it's solvable from our view. So it's for all of them true. Okay. We decided to investigate a little bit more the preferred approach. The preferred approach was the downgrade approach, and tested it first in a lab environment. So we developed a prototype, we implemented in the standard Mptcp in version 0.9. And here you see this lab setup where we tested it first. So we have host A and host B, both are multipath capable. And host A has 2 interfaces where A1 is the default route and A2 is a secondary path. Yeah, in the first test, the path that are both following, we introduced some variable packet loss on the default route. We had no packet loss on the secondary path, and the latency was the same on both paths. And what you can see now on the left side, we show the average handshaking time over the packet loss of the default route. And you see for Mptcp, the average handshaking time increased tremendously over the packet loss. And with 100%, it's not possible to establish any connection. And with our preferred approach, Mptcp rope approach, we call it, the blue line, there you see normally it should be a stable average handshaking time, but because of some imperfections of our current prototype, it's not really stable, but it shows a good indication that we are much better than with the standard Mptcp in case if we have a problem on the default route. now again the same test, but now we want to show the latency benefit, and the default route there we introduced 40 millisecond one-way latency, so no packet loss anymore, just a 40 millisecond one-way latency, and on the secondary path 20 millisecond one-way latency. So from theory, the handshaking needs 3 times the one-way latency, and that you can see now in the figure. So for Mptcp, we have around 120 millisecond handshaking duration. So it fits to the theory. And for Mptcp rope, we have 60 milliseconds, because there we benefit from the secondary path, which is faster in respect to latency. Now a real-world setup. There we have on the left side Mptcp capable client with 2 interfaces, which is connected to an aggregation server in the public internet hosted by us, where a transparent TCP proxy is running. And we try to reach a destination in the public internet through this aggregation server. Next. And in this setup, we try to download the 10 most popular websites and see what happens. Again, we introduced on the default route an additional 40 millisecond one-way latency. So that means the default route between the host A on the left side and the aggregation server. And on the secondary part, we introduced 20 millisecond one-way latency. Yeah, and what you can see now in the figure is the loading time over the different websites and the different approaches, the Mptcp or Mptcp rope. And yeah, you see in 9 of 10 websites there is a benefit by Mptcp rope. It's just in the case of vk.com where there's no benefit, but I assume again that it is because of the imperfection of our prototype. But the indication is clear from my view. It's much better with Mptcp rope in respect to the overall latency and also the bandwidth, because we have earlier the flows available. Yeah, first some general facts. Mptcp rope can protect Mptcp against network outages during the connection establishment. It can improve the user experience in terms of reliability and latency. Under most circumstances, loading times can be shortened by having maximum throughput earlier available. And we already did some reference implementation based on Mptcp version 09. And now, and that is the important point for me, that's a question I want to discuss with you. Is there in general a need for robust establishment? If yes, where should it take place? So I had already some discussion with Olivier on the mailing list, and there was one proposal from his side to do it in the application layer, so in the responsibility of a developer. I personally don't like this approach. I think it should be in the Mptcp layer. Though that we have multi-path capabilities from the very beginning of an Mptcp session. Yeah, the next question, won't we benefit from only robustness, or won't we benefit from robustness and latency reduction? Yeah, which approach in general fits best in future? So is it any of the third proposals I present today, or is there any other approach which can fit? How to integrate the Mptcp rope into the Mptcp standard or the implementation, and yeah, how to develop or improve the existing reference implementation and make it public available. How is the process if you're interested in that, and so on. But before I hopefully get some answers from your side, please the next slide, and then we will return. First, we have there's some detailed discussion about the downgrade approach we prefer, because there are still some I will not say unsolved problems, but there are some relevant points we have to discuss. Yeah, in the downgrade approach, or it's the same for the break before make approach, we duplicating the thin request, especially the MP capable. So at the end, we duplicating the key A, which is very important. And can you go back some slides to the beginning? Back. No. Yeah, one back. Stop. No, to the downgrade approach. Yeah, right. Next. Stop. One left. One back. Yeah. Okay. So as I mentioned, we duplicating the key A, and here you see host A and host B. So it's pretty simple. But what happens if at the same time there's a host C which try to reach host B, and by accident or by intention it uses the same key A? What happened then? Then we have a problem, because key A acts in the approach as an identifier that flows belongs together, and there we need some solution to handle this. So please back to the next last slide. No, yeah, before. Okay. So we have some ideas how we can mitigate the problem. So we cannot fully use it, but we can mitigate it, I guess. So we can reduce the time frame where we allow new SYN requests with the same key A. Or we can use some remaining space in the MP capable options, for example, to introduce some additional identifiers that flows belongs together. Also, we have to solve the problem of the address ID, because from the Mptcp standard, normally the address ID is 0 for the initial flow, and for all the others, it is then negotiated. And but maybe that we can solve in the same way that we introduce some additional information into the MP capable. In general, there's a question: is there a need to negotiate rope support between client and server, or can we solve it in another way? How is it with a fallback mechanism? There are some ideas, but it would be too much now for the presentation. But it's an important point. And yeah, that was also a point from Olivier. So in the BIS draft, there's not anymore a key A in the MP capable, which we sent with the SYN. The last days I had the chance to review the draft a little bit, and I think we can also succeed if we don't have a key A in the MP capable. But that has to be discussed. And there are also some other approaches. So there was from the NICT at IETF 97 a proposal which is pretty similar to our break before make. No, sorry, to our downgrade approach. And I had already the chance 2 days ago to discuss with Kian from NICT. And we aligned that we have the same focus and maybe work together on the draft or whatever. Yeah, and we have the API eyeballs, which can be implemented in the application layer, which is a possibility, but not preferred from our side. So now we can go back and maybe we can discuss the questions or in general the approaches.
Hi, Alan Ford. If we could go forward a slide, please, because this basically covers everything I was going to say, which is good to see you've picked up on it all. For example, the IETF 97 proposal, which matched a lot of this. But the biggest killer is, of course, there's no key in the MP capable in the BIS. But the semantics of the key simply aren't the same as what you're using. You know, it's a key. The pair of keys for the entities, once they're involved, once it's set up, have a semantic meaning, but you simply can't assume that two keys on the wire from two random IP addresses are the same thing. As you say, you have identified that as a risk, but as far as I can see, it's pretty much a showstopper more than anything else. But 64. But yeah, especially for a malevolent attacker rather than an accident one as well. So that's a concern. But I'm most curious, given you've identified all this, there's no point rehashing it, but I'm most concerned about how you see it working without the key. On that last point, you said you had a way around it. So.
Yeah. Okay. So if you don't have the key A from the very beginning, so it's missing in the in the first SYN, yeah, obviously then we don't have the information and we cannot use it as an identifier. But in the last acknowledgement, we have both keys available, and I think then you can make the decision on receiver side, for example, because but I assume the handshaking will be like that with without any key. Yeah.
You wouldn't have sent the same key B.
Sorry?
You wouldn't have sent the same key B.
Right. So then we would replace or if you talk about not sending the key A in the SYN, then we are not aware of it, and host B, the receiver, will answer with different key Bs.
Yes.
But at the end, if the acknowledgement arrives, again, the host B, then he can identify that flows belong together because of the key A, for example, or some other information, and then key B can be replaced internally.
The security alarm bells are going off all over my head on this, and I can't point to just one thing, but I feel very, very uncomfortable with this. That's why I'll leave it for just now.
Thanks.
Olivier Bonaventure, I think I totally agree with the use case. So there is a good motivation to do that. But my feeling is that looking at what has been done with API balls, because when you have IPv4 and IPv6, it's the same issue. You don't really know whether you should connect over v4 or over v6. There is similar work being done in the TAPS working group. So in the TAPS working group, there is work on an API where you can let the library or the API selects the good source address or selects the good transport protocol, and this is the same problem. And I think the advantage of doing that in the application layer is that you can have something which is generic for many applications running on the same system. So if you look at smartphones, for example, applications do not connect directly by using the socket API. They have an underlying API which is provided by the smartphone vendor, and it already takes care of selecting which source address to use depending on whether the Wi-Fi is available or the LTE is available. And so if you decide to use both, then you can use both in the API, and you can use a timer with whatever value you want, but that would be part of the, and this is completely hidden from the application. So there is a shim layer that does this for you without requiring any changes to the protocol. So I think the use case is really valid, and I encourage you to continue to work on the use case, but I would focus on looking at the application level solution, because you get almost the good benefits that you want, and the cost that you have is that you might open connections that are useless and that you reset already, but this is done by many applications, so this should not be an issue. And the advantage of the library is that you can remember what you have done in the past easily, and then you can avoid sending too many duplicate SYNs. While if you put that in the kernel, and the kernel would always send duplicate SYNs, then I would be concerned from a scalability viewpoint on the client and on the server side as well.
I completely understand what you said, and that was also some argumentation you had on the mailing list, I know. But then it's only the case of robustness we handle there, and we don't benefit somehow in. But
then it's up to the library to decide whether you want to have low latency. Because if you want to have low latency, then you just open over the parallel path and you get the connection that you prefer.
You are right. You are right. Yeah. Okay, but then maybe we have some network overhead because we send several requests and all but one we have to reset.
Yeah, but you can learn what is the network that gives you the best latency, and so you have some overhead at the beginning, and then, or you have some overhead on a regular basis from time to time. You just do the probing, but you don't have to do it for all connections.
And you also need support in all the socket libraries. You need it for Linux, you need it for macOS, you need it for
Yeah, but
whatever.
as I said, applications will interact with the shim library anyway, and TAPS is building this kind of library. And if you look at the NEAT project, they are writing this library, which allows to select transport protocols. And this is more complex than just selecting the source address. So this is they are doing a superset of what you need.
Yeah, but if it would be in the standard, I think it's more general. And all of them has to use it if they support Mptcp.
Yeah, but then as Alan said, we have the security issues and the fact that there is no TA in the scene and things like that.
If you talk about the timer solution, which is pretty similar, I think, to the Happy Eyeballs, then it guarantees robustness.
Yeah.
But it is supported from the standard itself, and every person or PC or whatever which uses Mptcp has the functionality. If you only implement it in some libraries, then we rely on the support in the libraries.
Yeah, but if iOS and Android decide to put it in their libraries, then by default everybody is using that.
Okay. Yeah. Thanks.
Christoph Pasch, Apple. I also want to say, yeah, this is really important work where basically it's really important to get a robust connection establishment. And in iOS, we have something that is called Wi-Fi Assist that is basically doing the timer-based approach. And to kind of reiterate what Olivier already said, the advantage of the timer-based approach is that as it's sitting inside the library, it's also independent of the transport layer protocol. So whether it's Mptcp, TCP, whether the server supports it or not, it just works. Like the application doesn't need to do anything. And another point also with the timer-based approach is, because of the timer, you're not constantly erasing Wi-Fi versus cell, because you want to favor Wi-Fi and only use cell if Wi-Fi really doesn't work. And you really want to avoid bringing up cellular at all cost, because it has huge power implications, but also implications for the carriers, because they need to maintain state and so on. So.
Yeah, thank you for your comment. But for me, it's the same. It's depending on the library, and yeah, I know about Wi-Fi Assist, and you already presented on Tuesday, and you need some time, I think, to detect that the Wi-Fi is not working. I don't know how your algorithms work, and maybe we introduce a lot of delay to recognize that there is a problem. That is the negative point of the timer-based approach from my view. Yeah. But the question is, what we want to have at the end? Is it just robustness or is it more?
Hi, Brian Trammell. I really like proposal 1, but I share Alan's sort of security heebie-jeebies when I look at it. We need actually to have serious security people throw some cycles at it to say that it's okay. The other thing that makes me less enthusiastic about it is that I don't see a partial implementation or partial transition solution to it. It's like we put it in the standard and then it's magically there. You need to have some negotiation as to whether or not you're a modified receiver that can support protocol 1, so that adds a whole lot more complexity. We have an enormous amount of implementation experience with option 3, racing and timing. It's a little bit slower, but looking at the cost benefit analysis on, okay, we get a little bit more latency for this much more complexity. Would this be done before MP Quick is done? I'm not sure it would be. With respect to implementing,
thank you.
with respect to implementing the timer in the protocol itself, in the Mptcp layer, it's worse than that. It's worse than just saying, okay, well, there's some efficiency problems, because you're going to be doing the other racing anyway, right? So now you have 2 different layers also racing stuff. So you're going to race V4 and V6 at the library layer, and then you have it down to the Mptcp layer, which is also going to be trying to race different paths on V4 and V6. And it just seems like that's a really good way to get extremely confused. So if you're going to have racing, the racing stuff probably belongs in one place. And I'll reiterate Olivier's pitch for the work that TAPS and the NEAT project are doing on that. Thanks.
Thanks.
Thank you, Marcus. I think we ought to Oh, okay. Last comment. Okay.
Anna Brenström. So I agree with the comments that have been on the mic already. I just wanted to add one thing, and that's it's also not the latency trade-off is not so simple. So it's not necessary that using both the paths is always going to give you the best latency, because if you want to have them both for robustness, you want to have them also for short flows. Once you get into the paths being heterogeneous, it's not necessarily always a win.
Can you repeat, because I didn't completely get you?
So what I was saying was that when you have two paths and they're heterogeneous, also if you just say, I want to have both of them because it's always going to give me less latency, that is not necessarily true, because when the paths are heterogeneous, you may not want to use both of them. It may actually make it slower because you may get traffic on the slower path and it could dominate the completion time.
Yeah, right. That's true, but it depends on the scenario where you want to use it. Yeah, absolutely.
Sure, but so I think you need to separate the robustness and the latency in that sense. I mean, it's not.
At the end, I think if you have both, you can decide whether to use the path from the scheduler view or not, for example. So if a path returns first, which you don't want to use, then you don't use it. That is.
Yes, but then you still have to wait to see if the other one
succeeds,
right? So
yeah, it's tricky, right?
Thanks, Marcus. We need to move on because we're behind schedule now. Quentin.
So hello everyone, I'm Quentin from UC Louvain, and this is a proposal for fast subflow creation. So why do we propose this? Is the fact that, for instance, current implementation typically initiate a connection and then they create subflows on all pairs of IP addresses. And this is great for bandwidth aggregation, but in the case of, for instance, smartphone, this is not useful, and in fact, it can be worse than what we want, in the sense that you will establish subflows that might be useless because you don't have enough data to send, or because, in fact, you don't need bandwidth aggregation. Instead, in the case of the smartphone, you rather want to have a low latency and, seamless network handovers. So when you leave the Wi-Fi, you want to switch on the cellular in a seamless way. And useless cellular subflows consume energy consumption and radio resource allocations. So, for instance, with the smartphone use case, suppose that you start with a smartphone which is in a Wi-Fi network that works well, the connection established, and so on. And then next, please. And then you decide to move, and you are in a zone, in an area where you are losing the Wi-Fi reachability, and so it becomes lossy. And then in this case, you want to have an additional subflow in that case that will use the cellular, and you don't want to use the cellular if you are on a Wi-Fi that works well, and you don't need bandwidth aggregation. So next. So in fact, this work comes from a technical report that was recently published, and so we have three mechanisms to enable this on smartphone. In the case of the IETF, we will focus only on the last proposal, because it is the only one that affects interoperability, and so this is why we will present the multi-path TCP option to do that. So next slide. So the idea is, in fact, we want to have a break before make approach at the subflow level, and we want to delay the creation of the backup subflow, in your case, the cellular subflows. So yeah, this is nice for radio resource allocation, for energy consumption, but yeah, it's a kind of reactive approach. And so you have you need some time to detect if you really need to create a cellular subflow. And so you can have larger latency. And yeah, you don't want to have too high latency, and this is annoying in this sense. And furthermore, establishing subflows in multipass TCP takes some time. So next slide. As shown here, actually, when you want to, you have your smartphone that has data to be sent, and you want to create a new subflow, you have to wait 2 RTT before actually sending your data. And so, yeah, if the latency of your cellular network is quite high, you will wait much, you have an increased latency, which is annoying. And so, yeah, if we could create subflows in a 1 RTT or even in a 0 RTT fashion, it would be nice. If we could do some kind of TFO, but at multipass TCP level, using multipass connection information to establish this subflow, it would be great, because you can send the data in the SYN, and then you can have the answer just after the SYNAC. And so it's just the latency of sending data on the cellular, if in this case. So next slide. So if you take the case of request response traffic, here we made simulation with a mini net topology. And so we look at the latency experience by the application when you lose the first pass, and then you try to send your data on the second pass, the backup path. And we see that compared to the classical joined way of doing things, you earn at least 1 RTT, you save at least 1 RTT when requests are quite large. And if the request fits in the SYN packet, in fact, you can save 2 RTT. The 2 RTT of the establishment of the subflow, which could be nice, in fact. So next slide. So about the proposal itself, the concrete proposal, we want to have two additional multipass TCP options. A first one that would create a subflow when you want to send data. So typically when you have a request response traffic and the client detects that your Wi-Fi is bad, and so you will send your data directly in when creating the subflow. Or another option when you want to create a subflow, but the client has not data to send, but it knows that it has data to be received. For instance, you are in the middle of a build-up road, and for some reason, this is the subflow, the connection on which you are receiving data is lossy, and you want to say, okay, I think I will open the cellular and see if I can continue my transfer on the cellular. And this is the case for the other one. So next. So this is kind of a proposal like we implemented it in our technical report. So this is the option we should use in the SYN option to create quickly a new subflow. So compared to the multipass MP join option, here are the following changes. The first one is that we will include the data sequence number, because you need to know which data sequence number the data correspond to. Of course, you need to have a data level length like in the DSS. And because of security consideration, you want to authenticate in some way your subflow, and so you use IHMAC, truncated to 4 bytes. We will discuss this after that. And so to compute the HMAC, you can use the token of the connection and the DSN of the data you want to send. So next. And this NAC, in fact, can directly send a HMAC, compute it over the DSN and the data hack that is present on the connection. So next. And we have a similar way of doing things with when you don't have data to send, then you use the data hack itself, and you can compute a HMAC using the data hack and the token of the connection. And similarly with the SYNAC, we use the DSN of the flow. Yeah, so next. So of course, this introduces security considerations. The first one is that in the MP join, I think it's 8 bytes and then 20 bytes of the HMAC. Here we shorten, especially in the fashion out option, the HMAC to 4 bytes because of TCP option space consideration. Of course, we can modify it, but this is mainly to fit in the Linux implementation of TCP. And the second thing we should be aware of is about SYN reprior attacks. When you have the DSN, you have the data, you have the HMAC, so you can replay the packet on another subflow and create additional subflows with the same packet if you have seen this packet in the network, which is quite annoying. And so we can say, okay, the server should limit the number of subflows that are created for a specific DSN over a specific connection. This is a possible way of mitigating this. So next slide. And so to conclude, in fact, this is a proposal to tune Mptcp itself to fit the smartphone consideration because of the case of the cellular and the mobile nature of the smartphone. And we actually implemented this solution inside Mptcp 0.91 and in Android 6.1 on Nexus 5. And so is there any interest to follow up this work, at least at the IETF? Is there any follow-up for this proposal? This is the main question, in fact, for this presentation.
Hi, this is Uma. We are looking at low latency applications for a couple of use cases in 5G and related. 5G requirement is 1 milliseconds, but we don't go that far. But the low latency is very, very important topic.
Mm-hmm.
I just wanted to ask, what is the comparison after subflow creation and with your changes? What is the gain you got with this with your approach?
With the classical Mptcp?
With the classical and with your additions.
Okay. In fact, this we made that in the paper. We showed that for kind of interactive traffic, we can reach similar performance. Yeah, slightly induced latency, but not much more than classical Mptcp with the backup mode.
So the reduction is significant or not significant, the latency for the subflow?
The latency remains quite the same.
Okay.
It's just that you don't have the cellular, which is established useless.
Okay.
So if you establish a cellular, it's only when you need to use it and actually you use it.
Okay. Thank you.
Any more comments?
Alan Ford, I may have just not followed it as you're saying it. I'm trying to. In your options, when you send them in the SYN, so before there's any data,
Yeah.
what are you actually signing with the HMAC? Because you mentioned signing data acts and data sequence numbers and so on, but there's no data in that packet to sign. The data comes later.
I'm not sure.
Data doesn't come till the third ACK. If you're sending data out, the first SYN doesn't have data in it, presumably.
In the fashion in or the fashion out?
Out, as in you're the one who wants to send data.
Yeah. So the idea is to use the data in the HMAC. Or we could use the HMAC in the data.
What's the data sequence number referring to there?
The data sequence number of the connection of the data you are sending in the SYN.
Okay, but are you sending data in the SYN?
Yeah.
Okay, sorry, right,
It's a kind of TFO, but that's multipass.
Okay, all clear, all clear. That was a bit I wasn't too sure on, because I could see how it worked in the ladder diagram for the other way, but
Okay.
not this way. Okay, cool, fine.
Anna Brunström, so I'm curious about the impact on delay between your detection mechanism that you actually need to establish your new subflow in relation to the cost of setting it up. Because I guess the magnitude of those two are kind of important, I guess, to see the whole picture on the latency. Or
Yeah, in fact, the impact will be clearly visible if you have your main network, which has low latency, and your additional network, which is high latency, will have a much higher impact, because, in fact, the time you will have to create your subflow will be saved in some way. But yeah, when this is comparable, yeah, all is about having a good detection system, which is, yeah, we propose one in our work, but yeah, you have intense latency because of the detection, and yeah. I
won't stand up. So would this be a change to the base spec, or is this an extension that could be done later? To the protocol base spec?
For me, it's just adding two options, so it's like an extension. It's only an extension you can have.
But it would change the security properties by having this reduced age mode.
Yeah, for that option, yeah.
Christoph Basch. I think it's important that we speed up the handshake and that we can send data early. But for this particular use case, like when cell is down and idle, it takes a very long time to bring it back up again. And then basically the handshake is kind of in the noise. So I'm not sure if the gains that we see, we would really see them in the real world deployment. And then maybe a little bit more technical question is, it seems like we are missing the DSS checksum here. Maybe, or is the data level length able to cover middle boxes?
Yeah, no, we didn't include the DSS checksum, but we could.
Yeah,
we could.
Okay, thanks, Quentin. It sounds like this is something that needs more time for people to think about and discuss, but I've taken the message that we can go ahead with the BIS without worrying about this, because it's something you could add as an extension. If people think that's wrong, then we need to come to conclusion on it before. So we're up to Christoph talking about some thoughts about documenting interactions between Mptcp and TFO. Now, do we have some slides? Do you have slides? Or are you going to show it yourself? Okay. Can you send it to me afterwards so I can upload it? Yeah. So apologies, this one is not uploaded, but we'll do it soon.
Hello. So this is basically more of like a request to revive an older draft. It's basically the draft that Sébastien Gregory and Olivier wrote a few years back about the interactions between Mptcp and TFO. The draft is not suggesting any wire format changes for Mptcp. It's mostly documenting how one would implement an Mptcp and TFO Mptcp stack. And it basically boils down to two recommendations. One is on the TFO cookie size, because if we have Mptcp, TFO, and all the regular TCP options, then we need to make sure that the TFO cookie is small enough so that everything fits inside the SYN. And the second recommendation is about the data sequence mapping for the data that is inside the SYN, because it basically suggests to have the data that is inside the SYN to not be part of the DSS mapping, and the details are all inside the draft. Mptcp plus TFO has been implemented in Linux for RFC 6824 by Gregory a few years back, and it has been used, as far as I know, by many people. When I did the implementation of the BIS draft, I made sure that it works with Mptcp plus TFO as well, and in iOS we have it implemented also. So my request is kind of, can we maybe revive this draft, or maybe even include it inside the BIS document?
Alan Ford, I just wanted to say that I'd love to see this in the BIS, but that requires someone who isn't me to write the text.
That requires what, sorry?
Someone who isn't me to write it.
Ah, okay.
Okay, we will help.
Cool.
So any comments on the idea of including it, rather than who's going to do some writing? Michael?
So this is Michael speaking as TCPM chair. I haven't attended multipass TCP for quite some time. I just think we have to think in TCPM about whether we should move this at some point in time to standards track. And I'm not sure if this would be of interest to the multipass TCP working group. So far, TFO is experimental. So if there's input on that from the multipass TCP working group, that would be something we in TCPM would probably be interested in.
I've actually been discussing with Yushung of moving the TFO RFC to standards track.
Yeah, I know. I've also had quite a number of discussions. It hasn't happened so far. As personally, I think this is what should happen. But we have to think if we make it happen. But as I said, for this working group, it's mostly if you have input on that, then please raise it on TCPM.
So we heard one comment in favour of including this in the BIS. Are there any other comments in favour or against, or concerns? How many people feel ready? Oh.
Sorry, I just saw there's a question from Yoshi in the Jabber saying, do servers use different cookie sizes for TCP and MBTCP?
That is completely implementation dependent. In the Linux implementation, it just decreases the cookie size to 4 bytes for all TFO connections. We could simply change it to make it dynamic based on whether MPTCP has been requested or not.
I think there are two different elements in the slide that Christophe brought. So the first one is there is a recommendation on TFO cookie size, but this is related to the size of the TCP header in the SYN. And so as we move to 68, 24 bits, the requirements on using shorter cookies will be less strict than what it was with 68, 24. Oh. That's one issue. Yeah. But the second issue, which is really specific to MPTCP, is the importance of looking at the data sequence mapping for scene data. And so we might say that the TFO cookie size could be in or out of this document and could be in another document. It could be in a generic TCPM document where they recommend that whatever size you do should fit with the options that you use in the scene, because that's basically what needs to be done. And then there is a data sequence mapping, which is really specific to MPTCP. And I think this part should be in the RFC 6824 bis document. The cookie size is just an implementation detail. I mean,
True, agreed. Yeah, in the BIS we actually really don't care anymore.
In the BIS we have less issues because the MPKBL option is only 4 bytes.
Yeah.
So is anybody against trying to include something on these lines in the BIS? I guess, sorry, please hum if you are against. Please hum if it's too early to make a decision. You need some more time to think about it. And please hum if you'd be in favour of including something on these lines. So there's some noise on being in favour and not on the other two. So I suggest that Christophe, you and Olivier work on some text, and then we can discuss some specific text. And if you can try to do that in the next couple of weeks, something that would be cool. Oh, sorry, Julius.
Excuse me, Julius Krobacek, just a quick clarification. There was a question, I don't remember who at the mic, saying that TFO is experimental and MPTCP is standards track. Is that a problem or not?
Yes, so the intention is for the BIS to be standards track. Yeah.
And TFO being experimental, is that not a problem?
Michael is approaching.
Well, I'm not the best expert for these kind of things, but as I said, I think there is a certain interest in TCPM in thinking at least about a standards track thing. So if MPTCP would require a standards track specification, that I think TCPM could do something.
So we're saying that if MPTCP standards track TFO remains experimental, that causes a problem for some of this? Or I think I've interpreted your initial thing as just your initial comment as a plea. If you think TFOs should be standards track, please come and say.
No, I think if there was a problem, we could fix it in TCPM.
Okay.
I thought I'm aware there wouldn't be a problem with this. Well, Mia can probably answer, but it's informative in this draft, so it should be fine, yeah? Okay. Mia says that's correct. There you go.
Okay, so I think we have a plan. Thanks, guys. So Quentin, you're back on IPv6 only hosts. That's cool. This one. So it's, sorry, just before we start, has anybody not signed the blue sheet? Has everyone signed? There's one in the back corner. Thank you. And remind me, we're due to finish at 20 past? Yeah, okay. So perhaps 5 minutes because I want a little bit of time to wrap up.
Yeah, we will be quick. So, due to the availability of the IETF NAT64 here at the IETF, we decided to play a little with it. So it's nice. Yeah. Yeah, so let's take an example, in fact, of you have a client which is behind a NAT64 and has only an IPv6 address, and a server which has both IPv4 and IPv6 address given by two different networks. Next slide. So you can start initiating a connection on V6. So you will do the DNS request. You have the IPv6 address. Next. You send the SYN to the IPv6. Then you receive the SYNAC. Everything goes well. So next. Then you receive the address in V4. And next. And so what should the client do? Because today there is no real way for the client to detect the embedding of the V4. So next slide. So in fact, the client receives an IPv4, but it is V6 only. And the conversion of the embedding of the V4 address into V6 is actually done by the DNS resolver of the NAT64. And performing the conversion of the address in the NAT64 is probably a very bad idea, because we don't want to have additional middle boxes doing funny stuff. And you could have additional problem due to the TCP option space, because an IPv6 address is larger than an IPv4 address. So next slide. So what we can do instead is to try, the client could try to infer the embedding in some way. So for instance, here we are using at the IETF the well-known prefix, which is here. So when we receive an IPv4 address, it's quite easy to try to assign to that embedded address, and it's implementable. It was done, it works, it's nice. The only issue is that NAT64 can have the well-known prefix, but also network-specific prefixes. And inferring network-specific prefixes is quite hard, and it's quite hacky in some sense. And maybe a way to solve this is to rely on a draft that is currently done, which could allow the NAT64 via the DHCP to communicate the embedding of the network-specific address, the network-specific prefix. And that.
Yeah, this is Mohamed Boukada. Yeah, this is a generic problem for each time you have a protocol in which you have referrals. So there used to have RFCs, we have defined already means to discover the proxy which is used by the NAT64. You can see, for instance, an extension which is defined for the protocol PCP that you will use, for instance, to interact with the NAT64, and then you learn the list of all the prefixes of the NAT64, because you may have multiple NAT64 in your path. And then it gives the ability to provide this kind of prefix to the host, and then you will do the address synthesis based on the RFC 60, 50, 52 on the host itself. So this is a generic problem. The DHCP one is not an option, because there is a recommendation from the Behave working group to not go with that way. That means that, yeah, because various issues with the DHCP itself, it does not allow you to discover, for instance, if you have multiple NAT64 in a single network. With one single DHCP option, you don't have this limitation, and there is actually one RFC which go through all this list of alternatives to discover the prefix, and the DHCP option was discarded by the Behave working group. So the only proposal, the only RFCs in the Sonar track which we have today is the PCP, and this is really a problem which is shared by all the applications in which you have the address referrals.
Julius Krobacek, I'm going to use some strong vocabulary here, so I would like all the minors in the room to leave before I do. There is one possible point of view that NAT64 is a hack that doesn't belong in the internet, and I'm still hoping that there will be a sudden outburst of common sense, and people will be using things like MAP-E that don't have the problems that NAT64 has. I'm wondering about the wisdom to accommodate for NAT64 for NAT64 within Mptcp.
Yeah. Just one quick comment to Julius. Yeah, you said MAP-E, and MAP-E, there is a NAT in the CP itself. The only difference there is that there is a port restricted NAT in that CP, and you have the same problem to to get in for the communication for a host which is located behind TCP, even if you have the map in the network side. So the NAT will be always there. You have firewalls, and the problems are there. So I don't think this is the opportunity to say this is bad or not. This is the situation we have today, and the NAT64 is really deployment in many networks, and multiple customers, millions of customers are enjoying the service to have the IPv6 and the IPv4 service continuity, so that they can also join to the majority of the servers which does not support IPv6. So NAT64 is something which is really helpful for these people, and this is really a good problem to be solved. So what the comment is how to solve it. It is not specific to Mptcp, but that's another way. But this is not something that we should to say against NAT64 and so on. But anyway.
Olivier, I agree that NAT is a mess, but if we believe that one day we will have IPv6 only networks, then we will still continue to use IPv4, and so NAT64 is one way to get that. And the message for vendors and for network operators is that if you deploy NAT64, please use the well-known prefix, and there is some hope that we can cope with that with Mptcp. If you use any other prefix, then I guess nothing will happen, and we won't use the NAT64 prefix in Mptcp.
So if I get it right, this has no impact on the BIS protocol document. This is
not really. No,
Okay.
it's just to find an
highlighting
issue with the
highlighting a
network
problem.
networks. It's
Okay.
just playing with experiments and
Yeah, very good.
that's it.
Christoph, I just want to confirm that this is a really big problem where the device is on an IPv6 only network, and previously we were on an IPv4 only network, so we only have an IPv4 address. How can we establish a subflow over the IPv6 only network? And we are doing in iOS, we are doing a lot of synthesizing and desynthesizing of the IP addresses to basically extract. If we started on IPv6 only, we extract the IPv4 address out of it, and the other way around. And so even if they are not using the well-known prefix, we basically figure out what the prefix is by resolving IPv4 only.arpa. And that way we can basically use Mptcp on whatever network there is. So I think, I maybe even think that this could be documented in the BIS.
Okay. I'm very happy with this, and it's kind of an informational thing. It doesn't have any wire impact, does it? Yeah. No, I mean, that sounds great. If you can write something that people like in the near future, then that's great. Yeah. Okay. So I think we've got about 1 minute left, so I'll just summarize where I think we've got to today. So if I remember right, we're going to we've at least here agreed, I have to confirm things, of course, that the MP Prio, which is we're going to make the modification that we talked about, which is a wire change. We're going to have this TFO interactions stuff, which is more informational, and maybe something on what Quentin's just talked about. And we're going to try and get the BIS in its sort of. We thought it's been in a stable state for a while, but we keep making the odd change to it. So when hopefully this will mean it really will be stable in the next month. I guess all of these bits of text can be done, and then we're going to work out how to push it up into ISG land and wider review. We obviously have to do a working group last call first. I'm assuming, Mia, do you want to make any closing comments last minute? You're happy? Okay, right. Thank you very much to everybody. We've used our time up. It's the end of the IETF. Congratulations. See you or hear you in Singapore. Bye-bye. Thank you for all the good discussions and contributions. And if anybody didn't get the blue sheet, anybody sneak in?